Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on relational models. This is part of this database management system and also it is there in the IT of MBA department. In this relational model, just you observe it here. It is we call it as a table or a relation. Okay, what is the you see here? What is the table here? This is the table, maybe a customer table. There is a department table, whatever the table name is there. So it has a number of rows, or we call it as the tuple, and the number of columns also we call it as the attribute. You see here, first of all, the customer or the employee, it has a ID, employee ID, employee name, then the department name, and also the salary. So these are all attributes. You can see some light blue color is there. This ID one attribute, name is attribute, department name is attribute, salary is also attribute, right? And these rows are there. This we call it the tuple. That's why I call the tuple relation, right? So next we talk about the attribute type. From this diagram previous page we can understand the set of allowed values for each attribute is called the domain of that attribute, right? Remember the first thing. Then attribute values are normally required to be atomic, that is indivisible. We cannot provide more than 2 data in the same cell, clear? Then special value null is a member of every domain. What is the meaning of this null value? It is indicated that the value is unknown. It is null means it is not empty, it is unknown, clear? Then null value causes complications in the definition of many operators. Anyway, let us see here. Now the relation schema and the instance. Okay, the schema, what you see in a table, the heading is just represented as the schema. For example, the attribute we call it as the schema. In a relation, suppose A1, A2, A3, these are all the column heading A1, A2, A3, AN, these are called the schema. So we call relation R, which is a collection of A1 up to N. That's why I call it a relation. For example, I talk about instructor. So that table was instructor actually. I talk about a table instructor. It has attribute or schema like ID. A instructor must have a ID. Then the name of the instructor, department name. It belongs to physics department, mathematics department, engineering department, whatever things are there, and the salary. Now, for given sets D1 to Dn, relation R is set of that I will tell you what is the meaning of this thing. Formally, given a set D1, D2 to Dn of relation R, so that relation R, these are the different sets, and this is the subset of D1 into D2 up to Dn, and thus a relation is a set of n tuples where this AI belongs to DI. Now take an example from this, we can clearly understand. Relations are unordered. What is the meaning of unordered? That is not in proper order. For example, if you see the ID is starting with the say 5 2, then 1 2 1 2 1. This is not in order, alphabetically order or whatever the increasing or decreasing. It is not like that. So relations are, what is the relation? I am talking about relation here means the rows. Try to understand. The tuple is the rows. Okay. The relations are unordered. Order of tuples is irrelevant. Relation means this is the table, and order of the tuple means rows. This is irrelevant. So it can be any number can come. Not necessary. It will be in ordered manner. Then tuples may be stored in an arbitrary order. Example: instructor relations with unordered tuples. So this you can see clearly example, because these 2 is starting first, 1 2 is next, 3 2 again after that something it is 1 5 it is also starting. This is not in order. Okay. Then we talk about keys. So let K is a key. K stand for a key, which is a subset of R. What is the R? R is the relation. Capital R is the relation. Relations mean the table. So K is a super key of R. Try to understand all this concept. Capital R is the relation of the table itself, and these are consisting of a number of attribute or number of tuples, whatever number of things there. So K is a super key of R. If values of K are sufficient to identify a unique tuple, try to understand. K means it is the super key. K means it is a super key. So this you either take one value, that means one column or two column. Using this I will be able to uniquely identify one row of data. Okay, so then only we call it as a super key. For example, we are having id one key, id with name also is another key. Both are super keys for instructors, because we cannot make name as a super key. Why? Because with the same name there can be two people. For example, suppose you are in Andhra Pradesh, there will be n number of people with Venkateswar or Sai. Similarly, the people in Orissa or Uttar Pradesh are like that, Ram, Krishna, like that. So many students will be there, so many names will be there. That's why we cannot take it as a, because if you select something with the name, more than one or two items it appears, so it is unable to uniquely identify. That's why it cannot be super key. Say id with name, id can be super key because id of two persons may not be same, it should not be same also, right? So if it is same, then it cannot be a id along with name, it can be a super key, and id also can be a key. Okay, right. Super key k is a candidate key if k is minimal. Try to understand. Super key k, so this k I am taking is a super key. This is a candidate key if it is minimal. For example, if I take id, id is a candidate key. id is a candidate key. With id also I will be able to show one row of data. With id and name also I will be able to see. But when with id only I am able to show, so this is the minimal key. That's why I call it as a candidate key. And one of the candidate key is selected to be the primary key. Okay, the primary key is one of the candidate key. So similarly, we are having foreign key. Foreign key constants, values in one relation must appear in another. For example, suppose I say this is the instructor id, and suppose I am creating another project, that is another relation, that is project. There is also the instructor, and but there is a project batch. Project batch is there. So project batch can be the primary key there. Why? Because project batch 1, batch 2, batch 3. In the batch 1, the same instructor can be there. In batch 7 also the same instruction can be there. So we cannot create here instructor id as the key. You get it now? So in that case, so we can relate between the two tables with some common thing, that we suppose one key is a primary key in one relation or one table, the same key is appearing in another table, so this can be a foreign key. Try to understand, right? So foreign key constants, value in one relation must appear in another, then we call it as a foreign key. This is the referencing relation or reference relation. Two things are there. Example, department name in instructor is a foreign key. Department name in instructor is a in the instructor department name is not a primary key. Why? Because in the same department name there can be so many people, so it cannot be a primary key, but it is a key there. But it is a foreign key from where it is the instructor in a department, there will be some instructors. That means those instructor belongs to that particular department. Try to understand. So this key can be primary key in one table, and it can be a candidate key in another table, then we call it as a foreign key. Okay, see the example, you can understand. Then we take the example here, how we are using these things. So first of all, let me see, we have a student here, and the student is enrolled to a department here. Okay, and the department has instructor. You see, all are connected. Department has some instructor, and the student has some advisor, and this advisor, the instructor can be one of the advisor. Try to understand. The instructor he teaches. If he teaches, there will be some id, course id or section id or semester, all things are there. Then it teaches for a section. For this section also there will be section id and whatever things are. In this section there will be a classroom, some building number will be there, or room number will be there, or capacity of that room will be there. And this section, you try to understand, this section the student takes, or the section takes students. Okay, in each section there can be some minimum number of students. So this is how we represent in diagrams. Then the relational query languages, we are having two type of languages categories. One is the procedural, second one is the non-procedural, or we call it the declarative. Okay, procedural, non-procedural, or declarative, whatever you see. So procedural means we want this and I will tell the procedure how to get that one. Non-procedural, I want this one, but I have not mentioned the procedure how to get that one, right? So this way, these are the two categories, and we also define it as a pure language. Pure languages are relational algebra, tuple relational calculus, and the domain relational calculus. Three are the pure languages. Try to understand. One is the relational algebra, second one is the tuple relational calculus, third one the domain relational calculus. These above three pure languages are equivalent to, in computing power. So in the how we are computing there, no. So this is because we can put a query, and using that one we can retrieve all the data from this database. So we'll concentrate in this chapter on the relational algebra. Okay, relational algebra out of the pure languages, the first one is the relational algebra. So we are basically focusing on this relational algebra in this chapter. So this is not Turing machine equivalent, or it is consisting of 6 basic operations. What are the operations? Let us see. Now the first operation is a select operator. That means we can select, means what? We can select a row or we can select a tuple. How do? Suppose my relation, here relation means the table name. Relation means table name. Relation R means R, small r means this is the table consisting attribute A, B, C, D, and the tuples are these are the values are it is there. And suppose I want to select something from this table. What I am telling, you select means this row, select this one in the relational algebra. The first one, the relational algebra. These are the notation we are using. This row is the notation for selection. So selection from what? From the relation R, because the relation this is the R, the table is there. So select something from the table R. That is the select from R. Then here what is the condition we want it? When A is equal to B and D greater than 5. So A, B, alpha is there, and here beta, beta, alpha, A, B there, because alpha, beta it is not same. So alpha, it can be selected, or beta, it can be selected, or beta, it can, because A is equal to B and D is greater than 5. So D is greater than 5, here D is 7 greater than 5, and this case is cancelled because alpha, beta both are not same, and here D is less than 3, it is not selected. So these two are selected, first tuple, first row, the last row, these are selected. So what I will write? So for this I write A is equal to alpha, B is equal to alpha, and C is equal to 1, D is equal to 7, because it is satisfying the condition. The last one, A means here alpha, beta here beta, and C is equal to 23 and D is equal to 10. Are you getting me? So this is the way how you go for the selection operations. You can go for some or other things. Then we go for the projection or project operator. That is the selection of columns here. That is the selection means selection of rows. Here projection means projection of column attributes. Okay, column or attributes. See, the selection operation, we are going for selection of rows. I am selecting some rows, one row or more than one row of data. Okay. So here projection means I am going to select one column, either column A or column B, column C, or combination of these things. How for this? Can you see? Just I am using a notation just like pi. No, can you see it here? This is the projection. So relation R is given, the table name is R, and A, B, C, this values is given. Here I am telling from this relation means from this table R, project, select some columns. Which columns? A, comma C. So what is A? Alpha, beta, beta, and 10 bit. What is B? 10, 20, 30, 40. Are you getting me? Sorry, you want A and C. So it is 1, 1, 1, 1. Are you able to get me? So this you are getting, but you see alpha 1 is repeated. So it will not appear 2 times. It will alpha 1, then beta 1 and beta 2. So these are the two things will be projected. Are you getting me? So till now we studied two operations. One is the selection, that is selection of rows, and we studied about the projection, that is the projection of the columns. Then sometimes we go for union of two relations, because two tables are there, something common here and there. With that I can go for the union of the two tables. So for this, suppose the relations R is there and S is there. First one is the relation R, the table R. Second one is the relation S, the table 2. I want to make the union of these two. Okay, then how we do for this? R union U, U stand for union, and R union S. How we go for these things? Is telling alpha 1 is there, alpha 1 will be there, alpha 1 is not there here, but union maximum you have to take it, alpha 1, alpha and 1 it is there, then alpha 2 is available here, alpha 2 is also available here, so alpha 2 will be there. So beta 1 is here, so beta 1 will be here, because beta 1 even if it is not there, because it is here, again we have to take, and beta 3 even it is available in the table S and not available in table R, still you have to take that one. So this is the union of that one. Is it clear? Then we go for the set difference of two relations. Set difference, you see, so it is the minimum thing should be there or the common thing should be there. For example, you see here what will be there in R and that is not in S. Try to understand that thing. So for example, a relation R is alpha 1, alpha 2 and beta 1, and relation S which is equal to alpha 2 and beta 3. Then what is there in the first relation and not in the second? Alpha 1 is there in the first table, but it is not there in the second table. The alpha 1 will be there. Then alpha 2 is available here and alpha 2 available, it cannot be there. And beta 1 is available here but not available here, so beta 1 I can take it. You can ask out what to beta 3. Beta 3 is not available in R because it is R set differences, you cannot take beta 3. Is it clear? So it is alpha 1, beta 1, this is the set difference. Then we talk about the set intersection of two relations. Intersection means common between them. In the intersection you see, so relation R and S, two relation or two tables are there. R is a table consisting of these alpha 1, alpha 2, beta 1. Here alpha 2, beta 3. You see alpha 2 is available here, alpha 2 is available here. Remaining are not common in both the tables. So intersection will be alpha 2. Is it clear? So you note that R intersection S is equal to R set difference in bracket R set difference S. This is the relation. We can put it like this. Then we go for the joining of the two relations. That is, we call it the Cartesian product. In the Cartesian, you don't confuse Cartesian product and the union, both are not same, they are different, right? So how you go for these things? It is operated. That means alpha 1 operated on all this table and beta 2 is operated on all this table. Then that means alpha 1 10a, alpha 1 alpha 10a, alpha 1 beta 10a, alpha 1 beta 20b, all the things will be there. When alpha is completed, that means 1 2 3 4 times alpha will be there. Alpha is 4 times, then beta will be also 4 times. So beta 2 alpha 10a, here is starting beta 2 alpha 10a, so it is operated like this all. Okay, this is called the Cartesian product. So then we can go for the Cartesian product naming issues. For example, we are having two relations R and S, that means two tables are there. So I go for the Cartesian products R S. How do you go for these things? He is telling here telling A is having alpha beta, but here B is having 1 2, whereas here B is having these things. Then how you go for that one? Because B similar things are not, here is just a numerical value is 1 2, here is alpha beta is there. In that case I do for see RB and SB will be there. Try to understand. This B for R and this B for S. So R dot B, S dot B. How I go for that one? Alpha 1 alpha 10a, alpha 1 beta 10a, alpha 1 beta 20b, alpha 1 gamma 10b. All things are there. Similarly, beta 2 this thing, beta 2 this thing, beta 2 this thing, beta 2. You get it now? Now when we are talking about this one B of R, I am taking R dot B. When I am talking B of S, I am putting S dot B. This is called the naming issues. Clear? Then renaming the table. So you do it here. I think this is not that much important for you at this stage. Then we go for the composition of operations. So we can say we are having already a Cartesian product R by S. It is there already. We have gone for the Cartesian product. From this I want to select A is equal to C. A is equal to C, then you select all the things. Then if you go for that one, first R was there and S are there. I have gone for the Cartesian product and it is there. From this I want to find, select those things. Here select means select the rows when A is equal to C. A, C, alpha, alpha is there, then beta, beta is there, then beta, beta is there, then 3 will be there. Okay, A, C, alpha, alpha, beta, beta and beta, beta. You get it now? So like this we can get all things. Then joining to relationship, that is the natural join. Let R and S be relation on schema R and S respectively. Then the natural join of relation R and S is a relation on schema R union S. Just you go for the R union S. R union means S means, so what are the new relation we are creating? It will be union of first table and the second table. That is the thing. Okay. Say for example, how do you go for natural join? I am telling you. Suppose you are having two tables R, S. Okay. R is A, B, C, D with all these values, and S is equal to these things. Then we are going R natural join S. Then how you get it? So this is alpha 1 alpha A, up to this is your C D. Okay, A, B, C, D. Then only E is added because B, D is common. B, D is there, and one common value is there, only it will be added, other things will not be added. Try to understand. So now first one, alpha 1 and alpha A, alpha 1, C is equal to alpha A. First one is there. Then while I am going for here, E is only alpha is added here. Clear? Then coming to the second one, coming to the first one, alpha 1 alpha alpha 1 alpha A, then it is connecting to gamma. Why? Because B and D should be common. If B, D, what is the B and D? B, D, it is 1A. Here B, D 1A was there, and here second case, B, D 1A, this is the B, D, it is also available 1A common B, D. Then here it is gamma. Okay. So these are the two things taken from this first row operating. Then coming to the second row, here B, D common we have to see. 2A, 2A is there, 2A is not there, so we cannot take that one. Like that you have to take all things. So similarly for gamma, this is we have to take a for B, D means 4B. 4B is not available, so we cannot take this one. Here 1A, alpha 1A, alpha 1A it is already there, alpha 1A is already there, and so we can take this gamma because 1A alpha is already taken. So this is taken here like this. So like that you can go for that one. Suppose I want to go for the projection from these things. So from this A comma R of B and C R of D. So you know how to get it. You can do all things, right? Then some notes about the relational languages. Each query input is a table or a set of tables. Each query output is also a table. All the data in the output table appears in one of the input tables, and relational algebra is not turning complete. We can also compute the sum, average, maximum, minimum using all the things. Okay. So this is the summary of the relational algebra, and with this we conclude the chapter 2. In our next video we will be mainly going for this SQL, structured query language. Till then, have a good day and take care of your health. If you like this video, please do share with your friends, and also don't forget to subscribe so that all the new video reach to you without any hurdle, without any delay. Thank you once again.